Good morning, Year 5. I hope you're all well rested and you had a lovely break and you really enjoyed Christmas. It's so lovely to be able to speak to you again. Hopefully it won't be much longer before we can all meet up and see each other properly, but for now we need to do the best thing, stay at home and keep safe. Okay, so for maths today then, first things first, if you could please write your data and your skill today, which is read and interpret line graphs. Okay, make sure they are underlined. Okay, so you can pause the video whilst you write that out and then unpause it when you're ready to move on. Okay, so for today's arithmetic then, make sure you have got your 3 columns drawn out neatly. You have written arithmetic and underlined it. Okay, you have got 15 questions for your bronze challenge, 10 questions for your silver challenge and 10 questions for your gold challenge today. Remember to write the full number sentences out with the answers into your book, but your working out can be on a bit of scrap paper or a whiteboard for you, okay? With your arithmetic today, because you're not in school, it's up to you how you do it. As you know, in school we'll have a set amount of time and then you try your hardest to try and complete the challenge. However, as you're at home, you've got a few different choices. So you can choose to complete the arithmetic as quickly as you can and perhaps time yourself to see how quickly you did it, and then tomorrow you can challenge yourself even more to see if you can finish even quicker. You might want to go at your own pace and just complete all of them without any timing at all. Or perhaps you want to give yourself a 10-minute session and then you can time yourself and see how many you can complete in that time. It's completely up to you. Okay, what I would suggest is that you do pause the video now, okay, complete the arithmetic, and then when you're ready to move on, we'll go through the answers. Good luck. Okay, super job. So hopefully you would have done as many as you can. Okay, so go through the answers. Obviously give yourself a tick if you got them right. Most importantly, if you got all the ones that you attempted right, then give yourself a really big tick and a smiley face. Okay. If you did make some mistakes and get some wrong, then that doesn't matter at all. Okay, as long as you know where you went wrong, and so you know what happened and how you can resolve that and get it right next time, and that's excellent, because that is how we learn. We learn through our mistakes. So, great job guys, well done. Okay, so just before Christmas we looked at interpreting and comparing data and finding the sum and difference of discrete data. What is discrete and continuous data? I'm hoping you will remember. Okay. If you can you think of an example of each? So have a quick think about what we were doing just before Christmas when we did a class survey to see which flavour ice cream was the favourite. And then we also looked at tables where some children had school dinners and packed lunches. Okay, now they are examples of discrete data. So discrete data is counted in whole numbers. Okay, for example, the amount of children in a class, or the number of yellow cars parked in a car park. It could be red cars or blue cars. Okay, it's a set number, so it's a whole number. So continuous data then, there's a clue in the name there, is data that is measured. Okay, so for example, a dog's weight or the length of a leaf can be measured. The height of a sunflower, or perhaps the height of you, can all be measured. Okay, it's continuous data. It's continuously changing. Doesn't stay the same. Okay, so today we're going to focus on line graphs which use continuous data. So if we look here at this line graph, it tells us the temperature in Hawkinge over 12 hours. Down the side it's got temperature, and it's really important here because it's got degrees Celsius. It tells us it's not just 12, it's not just 14 pound, it's not just 8 stone, it's 8 degrees. Okay, and at the bottom we've got the time. Now you can see there's one missing here. What should this one be? If you're looking along the intervals, you can see they go up in intervals of 1 hour at a time. So this one should be 6 a.m. Do you remember which is the x-axis and which is the y-axis? So if we look along the bottom, we've got the time. Is that the x-axis or is it the y-axis? Now I'm really hoping that you're all going, it's x, it's across, okay? Because the x-axis goes across and y to the sky. Well done if you remembered that. It's a good tip. Okay, we're looking at this line graph then. How could a ruler help you to read this line graph? How could a ruler help? And I can hear you probably thinking, why do I need a ruler? Your brains are really shouting at me. She doesn't mean a ruler. I do mean a ruler. Okay, how can a ruler help you? Are you going to measure up these lines here? That's 2 centimetres. That's 2 centimetres. No. Okay. We are going to use a ruler because if I said to you, at 10 a.m, what was the temperature? You might look at this line here. I think, oh, there's 10 a.m. And then you could use your ruler to go along this line here to find that it was 6 degrees Celsius. Okay, so it actually does help you line up the data. How is a line graph different to a bar chart then? So if you look closely at the placement of the interval labels, what do you notice? Okay, do you remember when we did our bar charts and we looked at the comparing and the comparison of the sum and difference? Okay, we had columns that were filled with different colours and we were looking at the differences. And in this bar chart, this 7 a.m, or it wouldn't be 7 a.m, say a yellow car, there'd be the label here, and then you'd have 10 yellow cars and you'd colour this section in. If you had red cars and there were 12, you'd colour this section. However, with a line graph, we stop at each line. Okay, so each line has data. So how could we estimate the temperature at 7:30 a.m? Now this is where our ruler comes back into play. We know that 7 a.m. is here and 8 a.m. is here. So we know that if we use our ruler about halfway, so it's halfway between 7 and 8 a.m, we can move our ruler up slightly, up here, and then we can stop there at the data. Then we're going to go across. That's about halfway between 2 degrees and 4 degrees, which we know is 3 degrees. Okay, so we know the temperature at 7:30 a.m. was 3 degrees Celsius. That is how a ruler can help us. Okay, so what's different about this line graph then? What do you notice about this line graph? Straight away you can see that the line is slightly different. It's a dotted line rather than a full line, but that doesn't matter. Okay, it's just a different way of showing the data. What it does show us, and which I really hope you've noticed, is that although there's still a y-axis and an x-axis, the y-axis actually goes down below 0. So we're going into negative numbers. Okay, this does happen and you will come across these. It's really important that you are familiar with them. Okay, so sometimes like this one is showing the temperature in the garden, just means that in this case, just before 4:30, the temperature dropped below 0. Okay. So let's have a look closely then. What was the temperature at 3:30? So we know 3 o'clock's here and 4 o'clock's here. This must mean that this is 3:30. So we can go up to here. Then we're going to need our ruler again because we need to go across, and it's a little bit above the 1. So we need to go across. So we can say it's about 1.25, so 1 1/4. Okay, so it's just over 1 degree Celsius. So we're estimating. When was the temperature 4 degrees Celsius? Okay, so this time we don't need to start along the time, then the x-axis. We need to go straight to the y-axis because it's asking us the temperature. So we know the temperature is 4 degrees and it's asking when was the temperature 4 degrees. So 4 degrees only happens once, and that's in the very first line, which if we go down, we can see it's 2 p.m. What was the difference in temperature between 2 p.m. and 3 p.m? Now, we've done a lot of practicing with the difference and the sum and comparison of data. So we can see that at 2 p.m. it was 4 degrees Celsius, and at 3 p.m. it was 2 degrees Celsius. Okay, so we're going to find the difference. So we're going to take away the 2 degrees from the 4 degrees, which means there is a difference of 2 degrees Celsius. And then finally then, let's estimate the temperature at 6 p.m. Okay, so where are we going to start this time? What's the first piece of information that we know that will help us find our data? Okay, it's the 6 p.m. So we can go straight there, and we need to estimate the temperature. So we need to find our data. So our data is down here. And if we get our ruler out and we go across, we can estimate that the temperature was negative 1.5. It's between -1 and -2. Okay, good job, well done. Okay, let's have another look at a different chart this time. So it's still a line graph. This time you can see the little crosses where the data is plotted, and then the lines which join them up. Okay, so this one shows us population growth, and our y-axis shows us population, and it's really clear that we know that the population is in thousands, because this isn't just 70 people and this isn't 20 people, it's 20,000 people and 70,000 people. That's really important that you look closely, because if you answered a question like this and you said that the population was 20, it'd be wrong because it's 20,000. And at the bottom across our x-axis we have the years, so from 1975 all the way up to 2015. Okay, so what was the population in 1985? Okay, so this question tells us we need to look at 1985 first. So we're going to find 1985 on our line graph. Okay, it's here. And then we're going to go up and we are going to stop at the cross, and then we are going to go across to where it shows us it was 40,000. So the population in 1985 was 40,000. How much did the population grow between 1990 and 2010? Okay, so we're going to start with 1990. We're going to go up, and it's not on 40, it's above 40,000, and it's less than 50,000. I'm guessing it's around halfway, so I'm going to say 45,000, and then it goes up to 2010, which goes up to 90,000. So how much did the population grow between 1990 and 2010? So the difference between 90,000 and 45,000 is of course 45,000, which is the difference. So that's how much the population grew. When was the population double the population of 1985? So again, it's given us the year, so we can go straight to 1985. And if we go to 1985, we can see it is 40,000 people. The population is 40,000. When was the population double? Okay, so we know it's 40,000. If we double it, it's going to take us to 80,000. So if we go up to 80, and then we can go across, and then we can go down, and we can see that it was double the population in 2005. Okay, great job. Okay, So now it's time for your independent practice. So under the resources, you have got some different challenges, okay? You have got a cool, a mild, a spicy, okay? I think you can all do cool, so I would really, really like it if you could try the at least mild, really, okay? Give it a go. If you want to go straight to spicy, that's fine. You might want to do all three. It's completely up to you, okay? It depends on how much you're enjoying your learning. If you want to go straight for spicy, that's fine. And if you'll find it a little bit tricky, of course, just go down to mild. It's not a problem. Okay, so stick the sheet into your books. If you can print them, that's super. Work through the questions and you can just write the answers on the sheet. No need to rewrite them. Okay, and of course, if at any point you need any further help, just rewind the PowerPoint, go through it again if you like, okay, or if you need to. But most importantly, just try your best, okay? It's your first piece of learning since before Christmas, which is quite a long time ago now, okay? So just really try your best. And of course, if you would like to, you can message me on Discord and I will try to respond as soon as I see the message. Okay, and I'd really love it if you do some work and you're really proud of it, just send it across to me on Discord and I can have a look at your fabulous work. Okay, so have fun doing that. When you're ready, come back for your final thought. Okay, let's see how clever you are then and how much good learning you've been doing today. So match each line graph to the correct statement. So first of all, we can see we've got 3 line graphs. Okay, the first one, well, they're all on the x-axis tell us the time, and the y-axis show us the distance from the start. Now this one's in a straight line. I wonder what that means. This one goes up then down, and this one just goes straight up as a diagonal. Let's see if we can match them to the statements then. So looking at this one, a car drives to the end of the road and back. A car is parked outside a house. A car travels at constant speed on the motorway. Okay, so let's start the first graph. Which statement do you think it links to? So we can see that the time here, the time continues going along. The distance doesn't change. Which one could it be? Could it be a car drives to the end of the road and back? A car is parked outside a house? Or a car travels at constant speed? Hopefully you would have got the right answer, which is a car is parked outside a house, because we know that as the day goes on, as the time goes on, the car isn't moving, the distance isn't going up. So looking at this one, number 2, it goes up to a certain point and it goes down again. Okay, so it goes from one distance and it goes back to the same starting point. So which one could this be? Is it a car drives to the end of the road and back? Or is it a car travels at constant speed on the motorway? Hopefully you'd have got that. It's the car that drives to the end of the road and back. And then finally, and lastly, obviously, a car travels at constant speed on the motorway. It's showing us that the time goes on, the car's getting further away from the distance. Super job. Well done for your first piece of learning today. Enjoy the rest of your day. Keep working really hard, and I'll be back again tomorrow.